Hi, my name is Dr. Nusrat Khalili, and today I will talk to you about water conservation outside your home. This is the third of a series of four workshops. My first seminar was on the global water crisis, and my second seminar was about water conservation inside your home. You can find recordings of both on Bay Area Older Adults videos page. The last seminar is about the rebates and resources available to help fund the water conservation projects. The goal of these seminars is to make you aware of the water shortage in our community and around the world and what actions you can take to reduce your water bill and make our community sustainable. This lecture is timely. In fact, 88% of our state of California is in extreme drought, and 46% is in exceptional drought. This is a Bay Area Older Adults presentation, which I will call BAO for short. BAO is a nonprofit organization that improves the health and well being of more than 42,000 adults age 50 plus each year through educational, outdoors, and social programs. For our first question, and to get an idea of how much you already know, which of these sprinkler heads is the biggest water waster? I want you to go to the polling tab and make your choice. Well, the correct answer is the fixed spray sprinkler. So this is what I'm going to cover in this talk today. First, we will cover some background, including a recap of our global water crisis lecture and conserving water inside your home. Then we will cover, if you're not ready to give up your lawn, what you can do to reduce water usage by retrofitting irrigation and replacing your grass with low water use grass choices. And finally, we'll talk about a full landscape conversion, that is, taking out your lawn and landscaping with low water use plants. First, the recap of the Global Water Crisis lecture. In 2015, world leaders agreed to 17 global goals, officially known as Sustainable Development Goals or SDGs. It is now 5 years on, and we have more work than ever to do. These goals have the power to create a better world by 2030 by ending poverty, fighting inequality, and addressing the urgency of climate change. Guided by the goals, it is now up to all of us, governments, businesses, civil society, and the general public, to work together to build a better future for everyone. Successful water management will serve as a foundation for the achievement of many of the 17 Sustainable Development Goals, SDGs, as well as for SDG 6, which is to ensure availability and sustainable management of water and sanitation for all. The 6 major water issues related to water management that we covered in the Global Water Crisis lecture were: number 1, water stress, that is, with regards to quantity as well as quality. Number 2, water sanitation and hygiene, that is the WASH goal or Sustainable Development Goal 6. Number 3, water infrastructure deterioration. Number 4, unsustainable population growth and development. Number 5, ecosystem destruction. And number 6, water-related disasters. Then we focused on water stress, having accessible water in quantity and quality sufficient to meet population needs. Now the recap of the second lecture in BAO's Water Conservation Lecture Series. Your water footprint is direct water use. What is on your water bill used inside your home and in your yard, plus your virtual water usage. Lecture 2 in our water conservation series focused on two out of these three parts. First is the part of your water bill that is attributed to indoor usage, and second is not on your water bill, that is the part attributed to virtual water usage. Now, today's lecture will focus on that third part, that is water used inside in your yard. Water used in your yard. Locally, outdoor water use is 50%, and nationally, it is more like 30% of the residential water use. Of that, up to half gets wasted. This water waste can be prevented by taking some of the steps we will go over in this talk today. So you can reduce outdoor water usage by increasing irrigation efficiency, by amending soil with compost or peat moss, and by doing a landscape conversion. That is, you replace your high water use lawn either with low water use grasses and ground cover, or even better, with low water use plants. You can also add a layer of organic or inorganic mulch. So, how do you retrofit existing irrigation equipment to increase your irrigation efficiency? The retrofit includes replacing your controller with a weather-based controller. Replace your sprinkler heads with rotor heads or rotary nozzles. Install sprinkler heads with pressure regulators, which reduce water loss by making sure sprinkler nozzles are operating in the optimal pressure range, since high pressure causes misting and loss of water to evaporation. Install sprinkler heads with check valves to limit water loss on sloped sites caused by low head drainage. High water flow rates waste water. Installing flow sensors save water by monitoring the flow of water through an irrigation system and alerting the irrigation controller to shut off when the flow is too high in case of valve or pipe failure. Also on this slide, you see the WaterSense label. WaterSense is a program started in 2004 by the EPA. So products that meet water conservation criteria get certified with the WaterSense label. Our local water agency, Valley Water, has rebates for equipment upgrades to help you conserve water. Here's a list of qualified equipment that you can retrofit into your existing sprinkler system, including irrigation controllers, sprinklers and nozzles, as well as flow sensors. Ideally, you want to just switch out some high pressure, high flow sprinklers for some low pressure, low flow sprinklers to conserve water. But there are some things that you need to consider first. Do you know the water pressure and water flow rate at your home? If not, you can measure it by purchasing a pressure gauge at your hardware store for under $10 and measuring at the hose spigot near the water main. Normal water pressure may be anywhere between 40 and 60 psi, but should not be above 80 pounds per square inch or psi. If your water pressure is above 80 psi, it is hard on your sprinkler system, on your plumbing in general, and on your water heater tank. You might want to add a master pressure regulator to control the incoming pressure. Now, the flow rate can be measured by seeing how long it takes to fill a 5-gallon bucket of water. If it takes 30 seconds to fill a 5-gallon bucket, then the flow rate is 10 gallons per minute, or GPM. It is important to know the flow rate because it limits the number of sprinkler heads that can be placed in any one zone. You can also use a flow gauge to measure flow rate. Replacing your existing irrigation controller with a weather based controller is a no brainer. The weather based controllers are more expensive, but they use local weather data to conveniently adjust watering to maintain a beautiful landscape and reduce water waste and save money. Also, Valley Water provides a long list of irrigation controllers with rain sensors that qualify for a rebate. Weather based controllers with rain sensors stop upcoming scheduled irrigation once it has rained a certain amount. These controllers deliver only enough water to meet the plant needs. In general, I find Wirecutter product recommendations quite reliable. I found they had the Ratio 3 and the Rain Machine listed, and these controllers are on the Valley Water rebate list as well. There are an infinite variety of heads, nozzles, and emitters to choose from, so we need to understand the differences for a successful retrofit. Important sprinkler head specs include operating pressure range, the radius, which is a measure of how far the water sprays, the flow rate in GPM, and the precipitation rate in inches per hour, the spray angles, which go all the way from 30 degrees to 360 degrees. Height, which varies, so the water stream is not obstructed by plants being watered. So you need about 4 inches or 6 inches of height for the nozzle to spray over the grass, for example. Usually, for water pressure of a certain psi, a certain head will cover a certain radius and dispense a certain amount of water in GPM. The precipitation rate, also called the application rate, is the inches per hour that the sprinkler head delivers. This number is important to know because plants need certain amount of inches per week. So this number determines your watering schedule. For example, a zone has plants that need 1 inch per week. The sprinkler in that zone produces 2 inch per week at operating pressure of 25 psi. So if you run the sprinklers in that zone for 30 minutes a week, like 15 minutes on each of 2 days of the week, that will give you sufficient water for these plants. And a fun fact to remember, the best time of day to water your plants is probably 1 or 2 hours before sunrise. The relevant parts of the sprinkler heads are as follows. The sprinkler head consists of a body, which may be fitted with a pressure regulator or a check valve. Then there's the riser, that is the pipe that raises the height of the nozzle. And then there's the nozzle. High pressure is a cause for water loss, and so it is important to control the pressure in the system and at the heads. The high pressure may cause equipment failure, and it also causes misting and fogging, so water is lost as vapor, as well as uneven distribution of water over the covered area. There are two ways to reduce pressure in your irrigation system. First, you can replace your sprinklers with new ones that have built-in pressure regulator. Second, you can add master pressure regulator and a mesh to the main sprinkler line that supplies water to the drip system. A second cause of water loss is on sloped areas where water drains from the irrigation pipes out of the lower sprinkler heads due to gravity. On sloped areas of the yard, replace your sprinkler bodies with ones that have check valves, which only allow water to flow when the zone is running and prevent drainage from the lower heads and pipes when the zone is not running. When retrofitting irrigation equipment, those old fixed spray sprinklers heads and zones are the biggest water wasters because they run at high pressure, causing misting, and because they deliver water at high rates of 2 inches per hour, so water is lost to runoff. If you are keeping large areas of lawn and you have pressure of at least 40 psi, replace your old fixed spray sprinkler heads with rotor sprinkler heads. A rotor is a sprinkler with a gear driven body and changeable nozzles that emit water as a single stream over an arc that is more or less adjustable. The rotor sprinklers can deliver water in large droplets slower than fixed spray sprinklers with a precipitation rate of 0.4 to 1 inches per hour. If you have smaller areas of lawn, less than 25 square feet, replace your fixed spray nozzles with rotor nozzles, also called rotators. A rotator puts out multiple streams of water as it rotates and is installed on a stationary spray body. Used for distances of less than 15 feet, rotary nozzles can deliver 0.4 to 0.6 inches per hour. For trees, you can use a bubbler, which is a more focused water delivery for deep watering. Their precipitation rate is 2.5 to 20 inches per hour. For newly planted trees, water at the root ball and water at the radius of the furthest branch for established trees. Valley Water has a list of sprinklers and nozzles that qualify for rebate, so do check out their rebate webpage for your retrofit needs. The low-pressure sprinklers deliver a small amount of water at the root of plants. They may be online emitters, microspray or microbubbler nozzles, or inline drip lines. Depending on the gallons per hour per emitter and how closely they are spaced, you may get 0.25 to 1.5 inches per hour precipitation rate. These emitters can be used to water individual plants, shrubs, trees, and ground cover. Ground cover is mosses, creeping thyme, sedum, or other low plants that fill up an area. Now that you know each sprinkler type, how do you figure out which ones to use and how to position them? You need to measure the parts of the property that need to be watered. You need to organize the location and type of sprinklers to give you the desired head-to-head coverage. This calculation is based on the radius for the sprinkler head, the precipitation rate for the head, and the water pressure in your home. This is one reason why I had you measure the water pressure for your home using a pressure gauge. So for areas greater than 25 by 25 square feet area, and if you have pressure of more than 40 psi, you can use rotor sprinklers to water that area shown in the blue zone. For areas less than 25 by 25 square feet, you can use rotary nozzles or rotators as shown in the red zone. And individual plants can use online or inline emitters as seen in the yellow zone. An additional rule to remember, always irrigate your grass on separate valve than your planter beds. And 2, you have to choose the right spray pattern for the zone and, of course, the correct angle for the position. Now, one common mistake is to try to match the GPM or gallons per minute, that is the flow rate of all the nozzles within a zone, instead of matching the precipitation rate, which is measured in inches per hour. You can save up to 40% of water in a rotor irrigation zone by proportionally matching the precipitation slash application rate for the rotor nozzles. For example, a rotor only covering a one-third circle should have a nozzle installed in it that is roughly applying one-third of the GPM that the nozzle in a full circle rotor in the same zone is applying. Hydrozone-based design is the design of your yard into zones so that plants with similar watering needs are grouped together. As you retrofit and reconsider your existing plants and zones, please consider areas such as the side of the house that serve no particular aesthetic role, could just be covered by pretty rocks or organic mulch rather than being planted and irrigated, especially given the extreme drought we are facing here in California. Head placement is perhaps the most important part of making sure your sprinkler system is effective and efficient. Make sure each hydrozone has full head to head coverage and water is not being wasted on the driveway or sidewalk. In deciding how to split up the zones, consider individual plant watering needs, which differ widely from the rule of thumb, which is 1 inches per week of water. In deciding how to split up zones, consider individual plant watering needs, which differ widely from the rule of thumb, which is 1 inches per week of water. Also, zones can be any size or weird shape, but do consider sunny versus shady areas since their watering needs would differ. Look at soil types, clay, loam, or sandy soils, which absorb and retain water differently. Each zone has its own valve, so it can have its own watering schedule. So, how much water does each zone need, and how often does it need to be watered? 1 inch of water per week is a good number to start with. If a precipitation rate of the sprinklers in the dark green zone is 2 inches per hour, then we need to run this sprinkler for 30 minutes per week. This could be split into 2 days, 15 minutes each. And remember, the best time to water is 1 hour before sunrise. Now, the first thing I had you do is measure the flow rate using the 5-gallon bucket test. The measured flow rate comes in handy when deciding how many sprinklers per zone. When you add up the GPMs of all the heads and nozzles in one zone, it should not exceed the measured flow rate of 10 GPM. If it does, you need to split this group of sprinklers into 2 zones. The measured water pressure is important because pressure determines the spacing between sprinklers. The rule to remember is that the water pressure at the head must exceed the distance between the heads. If the pressure is 20 psi, heads cannot be placed 25 feet apart. You need a pressure of at least 25 psi or more to go the distance of 25 feet. So let's have you go to your polling tabs and have you answer these questions. So hydrozones that I was just talking about are zones within the same with the same watering needs based on the types of plants you put in that zone, right? The sunlight levels, the soil type, or all of the above. If you can please go to your polling tabs and answer this question. And then when you're done with that, you can come back to the YouTube streaming tab. So I'm going to give people a few minutes to go to the polling tab. Okay, so the correct answer is all of the above. Now let's talk about soil amendments. The soil types we commonly have in our area are clay and sand. Amending the soil by addition of organic matter changes its ability to absorb water, to retain water, and makes the soil more nutrient rich and increases its ability to support plants. Next, I want to talk to you about landscape conversion. Landscape conversion refers to removing your existing high water use landscape, typically high water use grass, and replacing it with low water use grasses or ground cover. And if you can't let go of your turf mindset, let's do this again. Landscape conversion refers to removing your existing high water use landscape, typically high water use grass, and replacing it with low water use grasses or ground cover if you can't let go of that turf mindset, or preferably with low water use plants. Removing your lawn and replacing it with low water use native plants has the largest impact on water conservation. Valley Water offers a rebate program to help you pay for this project. They reimburse at $2 per square foot up to $3,000, but you have to meet their requirements, which are detailed on their website. Here is the overall process. You're going to measure the square footage of the lawn you plan to remove. You're going to have to remove the lawn, condition the soil, block the weeds. Then you're going to choose plants from Valley Water qualified list. You'll design your new landscape with the template provided. And then you're going to do the drip irrigation retrofit. Rainbird has a great retrofit kit, so you can literally just change out the sprinkler heads and install a drip system. So then you plant the low water use plants and fill in the gaps with mulch or rocks. If you are attached to that patch of green, you can replace your high water use grasses and with low water use grasses or ground cover. So you want to measure the area that you want to cover and add 5% extra sod. You need to pay attention to the areas of sun and shade as well as where the existing irrigation is as you decide on what you want to plant. First, you need to remove the existing lawn using a sod cutter that can be rented locally. Once the sod is removed, you need to rent a rototiller to till the soil and soften it up. The guy running the machinery will need to be rented separately. You are going to want to test the soil pH and nutrients, then make amendments to the soil, purchase the replacement sod, seeds, or ground cover. Next, you want to block weeds before you lay down the sod or plant and retrofit the drip irrigation. Once sod has been removed, the soil has been conditioned, the weeds have been blocked, plant grass designed to be low water use, designed for California weather, such as UC Verde buffalo grass, now called California buffalo grass, native California bent grass, and native mow free grass, or ground cover, such as sedum or creeping thyme. If you want to have the greatest impact on water conservation and you have let go of the idea of having turf, you could choose plants from Valley Water Qualified list. This list is really long to give you lots of choices, which is really great, but at the same time makes it difficult to choose. To get the rebate, you will need to replace 50% of the lawn square feet with low water use plants. If the lawn you are removing is 1,000 square feet, you need to plant 500 square feet of plants. You'll use the table to find the square footage of the plants in the third column called coverage and add up the coverage for each of your plants. If we decided on the first 5 plants, getting 3 of the fifth plant, their coverage adds up as 7 plus 13 plus 64 plus 28 plus 3 times 95, which is 397. You need to add some more plants until you get to the required 500 square feet of coverage. This is a list of places you may purchase low water use plants. I found a couple of nurseries that were most helpful: the California Native Plant Society and Linda Vista Native Plants. They had a full range of the native plants as well as the expertise. For those of you listening from the East Bay, we have listed some East Bay nurseries and then the Yerba Buena Nursery in Santa Cruz County. Now, City of San Jose and southbaygreen.gardens.org provide some design templates and other information for people looking to redo their yards. They offer a variety of styles. You should make sure to leave room for a path so you can walk among the plants and enjoy them. Also, check out some of the photos from landscapes that have completed the Valley Water Rebate Program. Design templates for areas outside of Santa Clara County can be found on the California Native Plant Society website, as well as the UC Davis Arboretum webpage. If you go to Calscape Garden Planner and answer 4 simple questions, it will generate some plans for your landscape design. There are some other online resources, free and paid as well. Now that we've chosen the plants, we need to dig the planting holes. The holes we dig for planting need to be twice the width and twice the depth compared to the plant root ball. For a 5-gallon plant, needs to be 18 inches wide, 2 feet deep. The soil in our backyard was so hard that we found the 18-inch auger to be a handy tool to dig these big holes. The clay removed from the ground can be conditioned with compost and will be used to transplant to the ground. The irrigation system needs to be installed or retrofit. We use the existing valves from our spray irrigation to make the drip system. We added the necessary pressure reducer and filter, and then laid the drip pipes, drip tubes, and emitters to deliver water to each of the holes. You can add 1 or 2 emitters per plant depending on their watering needs. The typical emitter may deliver zero point 0.6 gallons per hour. Now you can put the plants in the ground. The bare areas between plants and the pots should be covered with a layer of mulch and or rocks. There are several to choose from. This layer provides many benefits, such as preventing moisture evaporation, blocking weeds, preventing topsoil erosion, adding nutrients to the soil, and steadying the temperature of the soil for the plants. I have one more suggestion for you. I discussed retrofitting your irrigation equipment to increase the efficiency of your outdoor water use. Let's talk about how to care for and maintain your irrigation equipment so you can continue to conserve water. There are things you need to check on a regular basis. Check sprinkler function for blockage, breaks, orientation, obstruction, and coverage. Check the function of the irrigation controller. Make sure each zone is working. Make sure the rain sensor is working. Check your water meter and check for leaks at pipes, connectors, or valves. Check your filters at least once a year. Filters are especially important for a drip system. Also, keep an eye on that water pressure. So, based on all this information, I wanted to ask you if you could go to your polling tabs and answer this question. Which of the following changes do you plan to make in your yard because of what you learned here today? Oh, yeah. Thank you for joining me today, and thank you for your attention.